For today's lesson, we will be discussing about rational inequalities. So we will discuss first what is a rational inequality, and later on we will be discussing how to solve rational inequalities. So first, what is inequality? So inequality, it shows a comparison between different quantities or expressions using the symbols not equal, greater than or equal, or greater than or equal. So when you say inequality, we will not be using, of course, the symbol for equals. So again, the expressions are using these symbols only. Now when you say rational inequality, it uses any of the symbols not equal, greater than or equal, or greater than or equal, and contains at least one rational expression. So on the previous discussions, we already discussed what is a rational expression. So when you say rational inequality, of course, we will be using the inequality symbols, and it should contain at least one rational expression. Meaning, it is an expression wherein you can write it as a fraction. So this is an example of a rational equation. So it still involves rational expressions because we have here 5 over y plus 2, and then we have y over 2. But we call it as rational equation since we're using the equal symbol here. Now this is an example of a rational inequality. So this now becomes a rational inequality since we use now one of the symbols for inequality, which is less than. So again, that's the difference between rational equation and rational inequality. It depends on what symbol are we going to use. Now in rational inequalities, we have what we call as the critical values. So this is a number that makes the expression undefined or equal to 0. Since we're solving rational equations, that means it involves rational expressions. So there are values that will make the expression undefined. This is when the denominator is equal to 0. Now, how do we solve rational inequalities? So in solving rational inequalities, so first is we have to identify the critical values. After that, we will identify or create a table of signs. Then from there, we can now identify the solutions. So our solutions is given by intervals. So let's say we have this rational inequality x plus 2 over x minus 1 less than 0. So first thing that you have to identify are the critical values. Now how are we going to identify the critical values? Now since we have here expressions for the numerator and the denominator, so we have to solve them separately. So what you will do is to equate the numerator and the denominator to 0 and then solve for x. So first is we have x plus 2, we equate it to 0. Next is we have x minus 1, we also equate it to 0. So from here, we can identify the two values of x that will serve as our critical values. So x is equal to, this one will become negative 2. So this is the first value of x. Next is we have x equals 1. So from here, we have x equals negative 2 and x equals 1. Now these critical values, we will use this to create our table of signs. So these critical values will now divide our number line into parts or intervals. So next thing that we have to do is a table of signs. So here we will draw a number line. So we have here negative infinity, this one is positive infinity. And then we will place here the critical values. So of course we know negative 2 will come first, and then positive 1. Then let's divide it into intervals. So as you can see here, we have 3 intervals, negative 2 to negative infinity, negative 2 to 1, and then 1 to positive infinity. And then let's write here our numerator and denominator. Now let's focus with x plus 2 first. what will be the value of x that will make this equal to 0? So we computed it already and we know that it is negative 2. Again, if x is negative 2, then this expression will be equal to 0, since negative 2 plus 2 is just 0. So you just have to locate where is negative 2 in our table of signs. So here is negative 2, and then let's write here 0. Now, why do you have to write 0? Because if x is negative 2, then this expression x plus 2 will be equal to 0. Now, since we know that if x is negative 2, then the expression will be 0, we now have to identify what values will make this expression negative and what values will make it positive. Okay? Once you already identify the 0, it will be easy for you to identify what values will make the expression negative and what values will make the expression positive. Just remember the number line. We know that the numbers on the left of 0 is negative, and the values on the right of 0 is positive. So if this is already 0, that means the numbers beyond or less than negative 2 will give us negative answer if we substitute it to x plus 2. So therefore, here we write negative. So the purpose of this table of signs is for us to identify what will be the sign of the expression from each interval. So since this is already 0, that means the numbers lower than negative 2 will give us a negative value of x plus 2. Okay? How about the numbers above negative 2? So since this is already 0, if we get numbers above negative 2, that means it will give us positive value for x plus 2. And let's do the same thing for x minus 1. So for x minus 1, we identify which value will make this equal to 0. So we know if x is 1, then this will be equal to 0. And if we get values less than 1, and we substitute it to x, that will give us a negative value, because if x is 1, it's already 0. So that means this will be negative. And if we get numbers that is above 1, so if we substitute it here, then this will be positive. For example, I get 2. You substitute it here. So 2 minus 1, that is positive. If I get a number here, let's say 0. Between negative 2 to 1. So 0. 0 minus 1, that will give me negative answer. If I get here negative 3. So negative 3 minus 1, that is negative 4. So the sign of the answers is negative. So that's how you do the table of signs. All you have to do is to identify where is 0, and then on the right, that will be positive. On the left, that will be negative. Now, after identifying the table of signs, we have to identify now what will be the sign if we will be dividing the two expressions. Because take note, we're dealing with rational expression. Okay? So if the numerator is negative and the denominator is negative, so negative times negative, that will give us a positive answer. If the numerator is positive, the denominator is negative, so that's positive divided by negative, so that will give us a negative answer. If the numerator is positive, you divide it by a positive denominator, that will give you again a positive answer. Okay? Now from here, we can now identify the interval that represents the solution for our rational inequality. So you just have to go back to the given and then look at the inequality symbol. So here the symbol is less than. So that means we have to consider the values that are less than 0 so that this will be true. Now, what are the values that are less than 0? Of course, this expression must be negative so that it will be less than 0. So looking at the table of signs, the one that will give us a negative answer will be from negative 2 to 1. Okay? So that means the interval will be from negative 2 to 1 because it should be less than 0. Now, in writing the final answer or our solution set, so we have to look at the symbol. So since the symbol used is less than, That means the values, the critical values are not included in the solution. So how will you know if it's included? So it will only be included if the symbols used are less than equal or greater than equal. But if the symbol used is less than only or greater than only, then the critical values are not part of the solution. So please take note of that. And another thing is that in case the critical values are included, then we have to use a bracket. But if not included, we have to use parentheses. Okay? So going back to this, we know that the interval that will satisfy our rational inequality is -2 up to 1. Now, since the symbol is less than, so that means we know that -2 and 1 is not part of our inequality. Because first, -2 will make our rational inequality equal to 0. And for 1, if we substitute 1, the denominator now will be equal to 0, which will give us undefined. So that means -2 and 1 is not part of the solution. Okay? So to write that, we have -2 up to 1, and then we will just be using parentheses. So the solution set will be from -2 to 1, but the critical values are not included. So what are the numbers between -2 to 1? So we have -1, we have 0, as well as the decimal numbers. Let's have another example. Let's say we have x squared minus x minus 6 over x plus 1 less than or equal to 0. So first we have to identify the critical values. So for the critical values, we have to equate the numerator and the denominator to 0 and then solve for x. So for the first one, this is a trinomial. That means we have to factor this. So factors of x squared is x and x. Factors of -6, that will give us -1 if we add them. So that is -3 and +2. So -3 times +2 is -6. If you add -3 and 2, that will give us -1. And then just equate each to 0. So x minus 3 equals 0 and x plus 2 equals 0. So therefore, the critical values are x equals 3 and x equals -2. For the denominator, we have x equals -1. Now take note, this value here is already not part of the solution. Why? Because if you substitute -1 to this, the expression will become undefined because the denominator will be equal to 0. So we will just use this as the critical values for dividing our number line. But later on, so we have to remember that -1 is not part of the solution because this will give us undefined expression. Okay? Next is, let's write or create the table of signs. For the table of signs, let's write here the factors. So we have x minus 3, we have x plus 2. This is from the numerator, and then we have x plus 1. And then let's write the number line, so -infinity to +infinity. Now let's write here the critical values. So first is of course -2, and then next number to it is -1, and then we have the +3. So this again will divide our number line. If the expression is x minus 3, it will be 0 at x equals 3. So you just have to write 0 here. Okay, since this is 3. Next, if the expression is x plus 2, it will be equal to 0 if x is -2. So this is -2. So you write 0. This will be our mark. And then x plus 1, if this is the expression, it will be equal to 0 if x is -1. So let's write 0 here. Now, all the numbers on the left side of the 0 will give us a negative value, and all the numbers on the right side of the 0 will give us positive signs. So from here, since this is 0, so the numbers on the left again will give us a negative value, and on the right is positive. So same as on the other. So this one is negative, on the right is positive, positive here, and then negative on the left. Now all we have to do is to identify or simplify the signs. So let's identify what will be the sign for each interval. So here we have negative and negative. Since these are from the numerator, so let's multiply and then divide for x plus 1. So negative times negative is positive. Positive divided by negative is negative. Next, negative times positive is negative. Negative divided by negative is positive. Negative times positive is negative. Negative times positive is negative. And then last, positive times positive is positive. Positive times negative is positive. So we have negative, positive, negative, positive. Now to identify which will satisfy our inequality, let's look at the symbol. So since we have here less than or equal to 0, that means we will be considering the numbers that are negative. Okay? So those are, we have this, negative 2 to negative infinity, and also negative 1 to 3. So these are the intervals that will satisfy our rational inequality. Now to write our final answer, let's now write the interval here. First is negative 2 up to negative infinity. Okay? Since the symbol used is less than or equal, that means the critical values are included. So we will write here from negative 2 up to negative infinity, and then we'll use a bracket. But for negative infinity, we'll just use parentheses. Why? Because we don't know the exact value for infinity. Okay? So that's it. For the next one, we have negative 1 to 3. Okay, so I mentioned that the critical values are included since the symbol used is less than or equal. Okay, but take note, negative 1 is not part of the solution. Why? Because if you substitute negative 1 to the denominator, this will be equal to 0, or the expression now, or the inequality now, will become undefined. So that means negative 1 is still not part of the solution. So how are we going to write it? We have negative 1 up to 3. So 3 is part of the solution. So we will use bracket. For negative 1, we will use parentheses. Because again, it's not part of the solution. Now, if you have two intervals here, you have to connect them by the union symbol. Okay? So this is our final answer. So the intervals that will satisfy our inequality is from negative 2 included to negative infinity, union with negative 1 not included to 3 included. Okay, next let's have x squared plus x minus 6 all over x plus 1 greater than or equal to 0. So let's write the critical values. For the critical values, let's equate the numerator and denominator to 0. So let's do factoring. So this is x, negative 6. That will give us positive 1. So we have positive 3 and negative 2. So the values of x are negative 3 and positive 2. So you just have to equate to 0 each factors. Okay? And then for this one, x equals negative 1. Okay. So these are our critical values. However, negative 1 is again not part of the solution because if you substitute it to your inequality, the denominator will be equal to 0. So that means it will become undefined. Next, let's now create the table of signs. So let's write here the factors. So for the numerator, we have x plus 3, x minus 2. For the denominator, x plus 1. And then let's write or draw a number line. Negative infinity, positive infinity. So the values of x we have is -3, -1, 2. So of course -3 will be the one first here, -3, -1, and +2. So if the expression is x plus 3, it will be equal to 0 if x is -3. So we'll write 0 here. If the expression is x plus 2, it will become 0 if x is +2. So let's write 0. And then last, if the expression is x plus 1, it will be 0 if x is -1. Okay? Again, the numbers on the left of 0 will give us a negative sign, and the numbers on the right side of 0 will give us positive sign. So this will be negative, positive, positive. This one is positive, negative, 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 positive, and positive. And again, you just have to simplify the signs. So again, this is for the numerator. So we will multiply this and then divide by the denominator x plus 1. So negative times negative is positive, divided by negative, that will give us negative. Positive times negative is negative times negative, so that's positive. Positive times negative is negative times positive, that is negative. And this will give us positive. Okay, now for our final answer, so looking at the symbol used, it's greater than or equal to 0. So that means we're getting intervals that will give us positive signs. So this one and then this one. And since the symbol is greater than or equal, that means the critical values are part of the solution. However, again, -1 is not part since it will make the expression undefined. So to write, we have -3 to -1. So -3 to -1. So for -3, we use bracket. For -1, we use parentheses. Since again, -1 is not part of the solution. And then union. Next is we have +2 to positive infinity. So for 2, we have to use a bracket. For infinity, we will be using parentheses. And then that's it. That is our final answer. For our last example, let's have 2x over x plus 2 greater than or equal to 1. Now looking at this rational inequality, you will notice that the other side is not equal to 0. So it's equal to 1. Now in solving rational inequality, the other side of the inequality must be equal to 0. Now if it happens that it is not equal to 0, then that means we have to move it to the other side so that we can write 0 on the other side of the inequality. You have to move the +1 on the other side. So this will become -1. And then we have greater than or equal to 0. And then you simplify this side first. So you have 2x over x plus 2. Then you have to subtract 1. Okay, now since this is a rational expression, we have to express 1 also as a rational expression. And since the operation is subtraction, that means their denominators must be the same. So whatever the denominator of the first rational expression is, we will also use it for 1. So we will write here x plus 2. Now what will be the numerator? The numerator should also be x plus 2. Why? Because if you simplify this, x plus 2 over x plus 2, this will just give you 1. Okay? So the value did not change. We just express it in a different manner. So instead of 1, we express it as x plus 2 over x plus 2, so that we can combine it with another rational expression. So this is now greater than or equal to 0. So let's write here, let's write them as a whole fraction. So we have 2x minus the expression x plus 2. So for this, you can distribute the negative symbol. So you have 2x minus x minus 2 over x plus 2. Simplify, we now have x minus 2 over x plus 2. So this will be now our rational inequality. Now let's identify the critical values. So let's get the numerator, x minus 2 equated to 0. also as the x plus 2 equated to 0. So x is equal to 2 and x is equal to negative 2. So this is our critical values. Now let's create the table of signs. So we have x minus 2 and x plus 2 here. And then let's create the number line. So negative infinity, positive infinity. So negative 2 comes first. And then we have positive 2. Divide our number line so that we can have intervals. Now, if the expression is x minus 2, it will be equal to 0 if x is equal to 2. So let's write 0 here. If the expression is x plus 2, it will be 0 if x is negative 2. So let's write 0 here. Now, the numbers on the left side of 0 will give us negative sign. And the numbers on the right side of 0 will give us positive sign. Now, to simplify this, just divide the two signs. So, negative divided by negative is positive. Negative divided by positive is negative. Positive divided by positive is positive. Now, you have to go back to the equation. Now, you have to go back to the inequality. So, the symbol used is greater than or equal. So, that means we're getting positive symbols. So, we have here the first one and this is the second. Now, since the symbol is greater than or equal, the critical values are included. However, the negative 2 here is not part of the solution because negative 2 will make our expression undefined. Okay? So, the other critical values are included aside from negative 2. So, for our final answer, so we have negative infinity to negative 2. So for negative infinity, we'll use parentheses. For negative 2, we'll also use parentheses because again, it's not part of the solution. Then union, then we have 2 to positive infinity. So 2 to positive infinity. So for positive infinity, it's parentheses again. And then for 2, this will be bracket. Okay? Because it is now part of the solution. So therefore, this is your final answer. Okay? So this now represents the solution set of our given rational inequality. So that's it for today. I hope you learned something about solving for rational inequalities and see you next time.